Hi everyone, in this section we'll start using Kubernetes, which is one of the most essential tools that enables the DevOps to unify development and operations. So in general, Kubernetes is an orchestration tool that enables us to take any software solution to a platform as long as Kubernetes cluster is deployed. And we will talk in detail about each and every component of Kubernetes and we will deploy it in that section. So today, all major cloud computing providers are starting to offer Kubernetes as a service, freeing up the work that goes into maintaining and deploying a cluster. In that way, we can achieve a software solution that avoids vendor lock-in, being able to distribute the solution through the cloud. Vendor lock-in means that a customer is tied to a company or service without the option to move away from them. Kubernetes allows us to run solutions within the clusters, so you are not locked to a particular service or a company. In addition to that, Kubernetes performs container monitoring tasks. This way, it allows us to ensure desired number of containers to be up and running, bringing us clusters to high availability. So Kubernetes has clusters that are made up from different nodes, and those nodes are normally made from pods that offer services. So a node corresponds to a real or virtual machine that contains of services that are necessary to run the pods that it contains. And every pod represents a process that is running within the cluster and can be made up of one or more running containers. So the use of Kubernetes is not only oriented to the needs of the large companies, but also to the smaller scale projects for developers who want to create their own content outside the market. So some of the main features of Kubernetes are the secret and the configuration management. And so with secret objects, Kubernetes allows you to store and handle configuration information like password and authentication tokens securely. You can deploy and alter the application without having to rebuild the container images or exposing the stack configuration secrets. Kubernetes also allows us to scale our application because using it you can generate containers within minutes to meet the demand of your application. It also allows you to recover from error or crash in the server instantly by restarting or replacing the damaged containers. It also allows you to do load balancing. So we don't need external tools to generate services and load balancing outside the Kubernetes. So Kubernetes will take care of everything automatically, and it also assigns that to its own IP address and creates a DNS for the entire node. It also allows you to do an automatic deployment. So we can update our application or go back to previous version progressively, while at the same time will give the users continuous availability. So let's look at the main components of the Kubernetes cluster. So the elements that make up the architecture of Kubernetes cluster fall into two main categories: master components and node components. So let's look at those. Firstly, as a master component, you have the Kube controller manager, the cloud controller manager that connects to the Kube API server. Then you have a data storage that is also connected to the API server, and you have a Kube scheduler. So all of those are connected to our node layer, which consists of different kubelets or nodes and communicates to our master layer using the API server. So the master components are in charge of deciding which node each container runs on, maintaining the state of the cluster and ensuring that the desired number of containers are running at all times. It's also responsible for updating the application in coordinated manner when new versions are deployed. So let's look at each of the components of the master node. So firstly, as I said, the Kube API server verifies the configuration data for API objects like pods, services, controllers, and their cluster-related items. This component exposes the Kubernetes API and serves as a control plane front-end. At this point, the control plane nodes run the Kubernetes API server scheduler and controller manager. Those nodes take care of the runtime tasks to ensure that the cluster maintains the configuration. Then we have the kube control manager. It processes the control loop that uses the API to monitor the cluster share state and makes modification in order to move cluster from its present state to the desired state. Then you have the cloud controller manager, which is a daemon process that runs on the master node and is in charge of managing the cloud controls. And yes, those controls actually have dependencies with the main providers such as the Amazon AWS, Google Cloud, and Azure. Then you have down here also connected to the API server the kube scheduler. And this module is in charge of workload distribution as well as maintaining the relation between the pods in order to boost the cluster performance. And then you have the cluster data storage or the etcd, and this is responsible for maintaining all the status information on the cluster and its configuration. In large clusters, it can be distributed among several nodes that do not necessarily have to be master nodes in the cluster itself. So as the kube controller manager is one of the key elements of Kubernetes, it consists of four main controllers. The first one is the node controller, which is responsible for notifying and respond when a node goes down. Then we have the replication controller, which is responsible for maintaining the correct number of pods in the system. Then you have the endpoint controller, which is basically the glue that brings the pods and the Kubernetes services together. And finally, you have the token and the service account controller, which creates default accounts and API access tokens for each namespace. So normally, all the information related to the Kubernetes nodes and containers is stored in the etcd storage, and we have assignment as a key value store. The master components are in charge of making global cluster choices as well as detecting and responding to various events. Those components can operate in any server or cluster, but they are often started at the same machine when deploying Kubernetes cluster, and user containers are rarely executed on the same machine. So let's talk a little bit about the worker nodes right here. Now, firstly, here we have the kubelet, which is nothing more than a principal process that runs for each worker node. And this process is responsible to manage the node connectivity to the cluster, as well as keeping the cluster informed about various pods and workloads that are operating in its own node. To every kubelet, you have kube proxy connected. So the proxy module is in charge of managing and balancing various network flows, and it functions as a network proxy. It keeps track on the set of network rules and allows the pods to communicate with one another inside or outside the cluster. In fact, it uses the operating system packet filtering layer if it is available, and its main job is to redirect the traffic. And finally, the container runtime is a software responsible for running the containers, and mainly for that we're using Docker. So these are all the components of the Kubernetes architecture. I hope this lecture was clear for you guys. Thanks for watching, and in the next lecture we will talk about the Kubernetes object.